All right. Good morning. Good evening. Good afternoon. Good morning. Good afternoon. Good evening. Good night. Good whatever time you are watching this in. But anyway, let me just explain what's the purpose of this channel. The purpose of this channel is basically meant it's meant for students who want to pursue in STEM. Basically, not STEM either, biochemistry or because that's my degree, but or chemical engineering or etc. But the the purpose of like you're not gonna see like a biology, like if you're a biology student then don't watch this channel, or you may watch it if you want to pursue like if you are basically stuck in physics or chemistry or whatever. But it's meant for students who pursue physics, chemistry, and mathematics. All right, so it's intensive STEM. That's the purpose of this channel, and you're gonna see me doing problems from like in the middle of or maybe sometimes in the beginning of organic chemistry, or you might see me doing stuff like in the middle of trig or calculus or physics. So it's like a terminal, it's like a terminal tutoring account. All right. So let me just and now today we are explaining the kinetic theory. All right. So how kinetic theory. So basically, if pressure and volume, and what's the kinetic theory does. So what meant by kinetic theory, and temperature, and how temperature, helps establish the kinetic theory. All right. So uh, let's say we have a let's say we have a beaker. All right. And there is a water. All right. And then there is a substance inside. All right. So there is an NaCl or salt inside. All right. And temperature increased in about like 303 Kelvin. All right. 303 Kelvin, that means it's 273 plus 30. So around 30 Celsius. All right. So what will happen since the temperature increase? Well, the particles, the speed of the particles gonna increase. Why is gonna increase? Because the collisions of the particles will increase as well. So the collisions will increase. All right. That's the first thing that we need to understand about this. All right. When the temperature rises, and then the collisions will increase, that means the particles will speed up. So basically, it's like a temperature rising is basically like a catalyst in this reaction. And it's like a catalyst in this reaction. Catalyst. That's why like it's meant for STEM students. Like if you're a chemistry and catalyst, you already know, or biology, you already know that hey, catalyst is basically what speeds up the reactions. So it's like a catalyst. When temperature is increased, like a catalyst is gonna speed up the reaction. All right. And what if we have a balloon? All right. So let's just do a balloon. Let's say we have a balloon. A balloon. So we have a balloon. What the hell is it? No. All right. Mind my language. All right. Mind my language. Let's say we have a balloon. Sorry for my language. Let's say we have a balloon. All right, and we basically increase the size of the balloon, so we add air pressure into it, and since the pressure is added, what happened to the particles? The particles move faster. When the pressure is added, the particles move faster. All right. When the pressure is added, the particles move faster. All right. And so pressure means higher collisions. Pressure equals higher collisions. Collisions. All right. So that's one thing we need to understand. And another thing you need to understand is, let's say it's a volume. All right. If the volume decreases, that equals pressure increases. All right. And yeah, equals pressure increases. If the volume decreases, then the pressure increases. Well, why when the volume decreases, the pressure increases? Well, think about this, all right? Think about this equation. All right, so think about this equation. Pressure over volume equal pressure over volume. If the volume decreases, what will happen to the pressure to make the process in equilibrium? The pressure equals P goes up. All right, to make the process in equilibrium. All right, and equilibrium is also another thing we used to do in thermodynamics. All right, equilibrium is something we say like Kc equals product of the reactant and to see that equilibrium, and then we see if it's favorable or not. I'm gonna explain that later, but just this is so, and then also it can be explained by PV equals nRT. All right, it's also so the ideal gas law also explains the kinetic theory. All right, how? Well, here's how. If the temperature goes up, then what will happen? If the temperature goes up, to make the process equilibrium, the moles will be less. All right, to make the process in equilibrium, and then the rate is dependent on the moles. All right, so if it's it's actually dependable on the pressure. If it's torr, then we're gonna use the rate 0.008 something, or if it's kPa, then kilopascal, then we're gonna use 8 point 8 points. We're gonna use the higher rate, which is 8, and then there's a table explaining all that. So that PV equals nRT is the best way to explain the kinetic theory, and I hope that helps. If you need help, you can go to my channel, and there's an Instagram account. I have an Instagram account there. I can help you there, or if you need help in this channel, you can just type in the comments. So peace out.